Hello and welcome. My name's Josie Currie and I'm a Year 11 high school student at the Riverina Anglican College in Wagga Wagga, Australia. This is a series of brief interviews with some of the most significant leaders in STEM from around the world, and they're all amazing women. I'm passionate about science, technology, engineering, mathematics and medicine, or STEM as we say now, and I will pursue a career in STEM. So I'm honoured to be able to ask a few questions of some inspirational women in STEM. I really want to thank them all for generously taking the time to chat and, importantly, pass on their rich insights. Hopefully, other young women with an aptitude for STEM can take inspiration and guidance from their experience and insights. The role of these interviews is to inspire the next generation of women in STEM. Today I'm speaking with Dr. Michelle James. Dr. James is an assistant professor in the departments of radiology and neurology within the molecular imaging program at Stanford University. She received her Bachelor of Science in Pharmacology and Medicinal Chemistry at the University of Sydney, where she also earned her PhD in radiochemistry, neuropharmacology, and was awarded the prestigious University Medal. For nearly 15 years, Dr. James's research has focused on developing and evaluating novel molecular imaging agents to improve the way we diagnose, treat, and understand brain diseases. In particular, she's interested in designing new positron emission tomography radioligands for visualizing the neuroinflammatory component of Alzheimer's disease, multiple sclerosis, and stroke, with the goal of learning about the in vivo role spatiotemporal dynamics and different functional phenotypes of specific innate and adaptive immune cells in the very early stages of these diseases and throughout their progression. Dr. James is also very interested in applying these tools to track disease progression, guide therapeutic selection for individual patients, and serve as surrogate endpoints in clinical trials. Dr. James has multiple patented radioligands for imaging neurological diseases, 3 of which are currently being evaluated in humans. The slide is very busy, I know, and really this represents but a fraction of the amazing work published by Dr. James, but I want to ask Dr. James about some of these key publications during the interview. Thank you, Dr. James, for taking the time to chat today. What drew you to a career in pharmacology and medicinal chemistry, and what excites you about this space?
Yeah, so actually I was always interested in science and teaching. So I ended up doing a Bachelor of Science and taking a lot of different subjects and got really interested in pharmacology in particular, because I learned how just a tiny nanomolar amount of either your hormones or a medication could have a big impact on your physiology and could really help with diseases or change your mood. So just the impact of being able to design a molecule and on the body and how that could potentially be a therapeutic was what really got me excited in pharmacology. And in order to engage in pharmacological research, you need chemistry skills. So I also took on chemistry so that I could fulfill that interest area of being able to design molecules to help people ultimately. So that's what got me excited about it and into it.
Yeah, I think people really shine when they follow their passion.
Absolutely.
How would you describe your journey to a medical science career? Was it a direct path from high school to university and a career, or was it less direct?
Yeah, it was pretty direct. But as I was saying, in high school, I was really interested in science. I had a wonderful science teacher, Mr. Byrne, shout out to him at Woolaware High. He really encouraged me. So I was definitely interested in science and teaching, but I didn't know exactly what I wanted to do. And it wasn't until I was in university that as I said, in the first and second years, I thought about engaging in a career in drug discovery and development, because in particular, I was interested in brain diseases, because there really aren't many good treatments for those diseases, and there's a big unmet need there. So I thought I wanted to dedicate my life to drug development. But then I actually saw one lecture, just one, that changed my sort of trajectory in a way. And it was a lecture from Dr. or Professor, full Professor now, Michael Cassio, shout out to him at University of Sydney, on PET imaging. And it was an absolute sort of life-changing moment when I was looking at these images that he was showing, whole body images of glucose metabolism, which is FGG PET. And what that could show, it could help us detect cancer, because cancer cells need a lot of glucose, and it was highlighting that throughout the whole body. in a snapshot in a living person. And I thought, oh my goodness, we can actually visualize biochemical processes in a living person. That's incredible. Why don't we do that for everything? Why don't we make PET traces for everything so that we can understand diseases at their core so that we can better treat them? So at that point, I went down after the lecture to harass him a little and said, can I work with you? What do I need to do to be in this field? And I never looked back. I did an honors project with Professor Cassio and then a PhD with him, and really developed my love and pursued my love of developing these tools to better understand these diseases. And because really that's what we had to do to start with. We didn't have any good medicines yet for Alzheimer's and a lot of these CNS diseases, but having the tools to understand them and shed light on them, like PET imaging does, was where I started. And then from there, I knew that I wanted to run a lab and to be able to keep pursuing questions of interest through my own endeavors. And so in order to do that, I heard that going to do a postdoc was a good idea, learning from others in the field. And I was, at various conferences presenting my work, got connected to different folk, and heard about someone called Dr. Sam Gambier over at Stanford, and got connected to him through a lovely colleague, Dr. Stephen Meikle. So it's really about your networks and people that are helping and supporting you. That's a big deal. So I was able to go over and do a postdoc with Dr. Gambier at Stanford. And from there, just kept learning about molecular imaging, expanding my knowledge, and was able to start a lab of my own after many years of doing the postdoc and becoming an instructor. So it was pretty linear, a straightforward, a direct path. But I think it came about through a series of things that were a little surprising, and also the signs from the universe that was just confirming that, yes, like you're on the right path. This is really exciting. You love it. Keep going. So that's kind of the story.
Yeah, that's really amazing. I see you've published research on neurodegenerative disease and neuroinflammation. How are they different, and what challenges do you face developing traces for each?
Yeah, that's a good question. So neurodegenerative diseases is sort of a characterization or a classification of a range of diseases like Alzheimer's, Parkinson's, ALS, so anything where you're getting neuronal cell death, and that can happen due to a number of different reasons. And actually neuroinflammation is one of the molecular processes that can lead to and drive neurodegeneration, that can lead to, so it's when your immune cells become really hyperactive, and they're sort of angry, and they can that can then lead to a whole cascade of events that can end up resulting in neuronal damage and death due to the release of pro-inflammatory messages and things like that. But there are other aspects to neurodegeneration that are driving those particular states, depending on the disease. So it can be amyloid buildup or tau, sort of these proteins that become misfolded and accumulating in your brain, or in something like Parkinson's, that's alpha-synuclein. So there are a number of different types of misfolded proteins that can build up in your brain that lead to these neurodegenerative diseases, in combination with neuroinflammation, oxidative stress, a range of things that all sort of feed into these particular pathological issues that we see. So they're sort of similar but different. The degeneration is when you have the actual cell death, but neuroinflammation is one of the drivers. And so when you're thinking about developing PET traces for each one, you just need to know what is your exact target, and you need to be very smart about developing the right kind of molecule to allow you to visualize that target. So, for Alzheimer's, people have developed PET traces for amyloid plaques, and also for hyperphosphorylated tau. And for neuroinflammation, you can look at different immune cells and whether they're activated or not. And so it depends on your question that you want to answer, and which cells or which protein you really want to look at. And if you start there, you can develop the right kind of PET tracer. Does that make sense?
Yeah. We just finished our topic on the brain in our sports exercise health science class, so that's really interesting.
Oh, cool. That's great. Love that.
It's amazing work to be developing traces that help imaging neurodegenerative disease. Can you tell me a little about your patents and the role they play?
Oh, yeah, sure. So the patents, it's a good sort of thing to discuss early on. I wasn't so familiar with, how to patent things, why to patent things. When I first got into science, I wasn't even thinking about that. You're just like, okay, I want to discover something new, help people, do some science for good. But actually, getting intellectual property is very important. So protecting your ideas via a patent or patent. I'm losing my Australian accent, but I'm speaking American now. But anyway, it is important to do that. And the reason is because if you can protect some intellectual property around a new tracer that you're developing, that will become very attractive to pharmaceutical companies or other funding, external funding agencies that may want to help you develop that further. Or you could spin out your own company and then take that entity and develop it further so it can be a commercializable product. And you might think, well, what if I don't care about that? What if I just want to make these traces and share it with everyone and it can, benefit the world that way? Well, I used to think like that. And I learned that it doesn't work that way. Unfortunately, if there isn't intellectual property around something, it's very hard for people to take these entities to the next step because no one will want to invest that next big injection of money in order to take something into the clinic and to run these huge clinical trials. Like, what's in it for them to really do that? So that's why, I don't know if that makes sense, but that is actually just why it's important to do it. So you can get enough folk interested and sort of capital raised to get things into the clinic. It's expensive. Science is very expensive. Getting things into patients is expensive, running these big trials. So you need to be strategic from the beginning. And I've been lucky enough to have great mentors to help me with that along the way. And now our most recent patent, we have licensed it into our own company. So I started my own company on the side, very Silicon Valley. And we're undertaking that journey right now, fundraising and getting enough of that in order to take our tracer into the clinic.
Yeah. Thank you for that.
Yeah, you're welcome. It's a whole other world.
Yeah. In my introduction slide, I had screen grabs of several of your recent publications, and I wanted to ask about them. The first was in a journal, but at nearly 100 pages was almost a book, and has been cited about 1,000 times. You wrote a molecular imaging primer with the late Professor Sam Gambier. What does it mean to write such a transformative piece with a mentor of Professor Gambier's stature?
Yeah, well, I mean, honestly, it was an absolute honor. At the time, I was just starting out in his lab back in 2008 when we, really embarked on the journey of writing this book, and it really was a book. I remember when Sam contacted me about it and said, come into my office, and told me all about it. I was like, oh, that sounds like a lot. He was like, yeah, it's going to be a great way to really get into all the different aspects of molecular imaging. My background at the time was only in PET radiotracer development, and I was more on the chemistry side, whereas this particular article had to cover or span the entire breadth of molecular imaging. So everything from photoacoustics, all of the optical imaging techniques to MRI and so on and so forth. And all the disease applications. So the journal had said we want it to be the Bible for molecular imaging. And I was like, wow, no pressure. So it was a lot, but it was a fantastic learning opportunity and allowed me to speak with a lot of experts to get their sort of thoughts on the current state of the art within each of these niche fields within, that fall under the umbrella of molecular imaging. And yeah, I was really, really fortunate to be able to work with Sam on this and get his mentoring and guidance. And just really, really thankful that I got to do that with him. He's a wonderful mentor, and I miss him a lot. It's nice to have that paper to look back on.
Yeah, thank you for sharing that insight.
Of course.
You were one of a number of really well-credentialed authors on a quantitative PET roadmap article. You were also an author on a radiopharmaceutical chemistry consensus paper, where the authors were a who's who of radiochemistry. It speaks volumes to your stature in the nuclear medicine community. What are the challenges of collaborating on projects like this across so many institutions in multiple countries?
Yeah, I think the challenges aren't as great as you might think. Like seeing those author lists, there's a large number of folk that are all contributing and working on these projects and articles. But actually, we're really lucky in the field that I'm in, of molecular imaging and radiochemistry. Everyone is so nice and so supportive. They're your friends, they're your family. They become your friends and family very quickly, and easy to work with, easy to communicate with. Of course, everyone's busy, and if you're on different time scales and time zones like you and I are on right now, the coordination for meetings can be that's probably the most challenging thing, really. But otherwise, it's a dream to be able to work with all of these folk around the world and to be able to visit them, or to all meet up at these central locations when there's a big conference. That's when we do a lot of brainstorming, or we may be at other small meetings and we sit down and chat about some of the big issues in the field, and maybe out of that comes a paper or something like that. But it's basically not as challenging as it may sound, because everyone is really great and has a lot of different unique perspectives to bring to the table.
Yeah, that's really good to hear, because in high school, it's a struggle to get like 3 people working together.
Oh, I remember that. I was like, why do we have to do group projects? And there's always one person doing all the work. It's probably you, I'm sure. And the other people get credit for it. And it's the same thing will happen in university. So I apologize in advance, but it'll get better. It will get better. Hang in there. Just keep doing your best. And that's just, you can only control what you're doing. Don't worry about the rest.
What do you see on the horizon that would inspire the next generation?
Lots of things. You mean science-wise, or in general?
Science-wise?
Yeah, science-wise. I thought you were going to ask me about different fun travel plans. No. Science-wise, there's a lot. I would say AI, just like what we can do with it, I think it's very exciting. I'm just starting to really dig into that area myself, and I'm still a complete novice, but I'm just learning about how we might apply the tools of AI to better extract out information that we may have otherwise missed. So with imaging, I think that's a big deal, because we're just using the human eye, and that's great. But it only goes so far, because I think there are patterns that we're probably missing that are quite subtle, that a computer vision can really detect. The same goes for a lot of different things. We're using it to select molecules for us at the moment, to radiolabel which ones. We're using it to predict which ones will be successful or not. And that's, I think, really incredible. Something I always dreamed about doing. And now the reality of that is coming to fruition with things like AI. Another thing that I think is particularly exciting for the future, for people that are getting into this field, is the availability of different isotopes that you can work with for theranostic applications. Also whole body PET with the Explorer that Simon Cherry and the Davis crew developed. I know there's going to be one maybe arriving in Sydney at some point, which is very cool. I wish that I would have had that as a young student when I was in Sydney. But with that, we can get a complete picture of what's going on in any given disease. We don't have to be, take a reductionist approach and just look at, oh, you have a sore leg, let's look at your leg. But actually, things might be coming. There may be other aspects of the pathology in your body that's leading to the leg pain. And I do a lot of pain imaging, actually. And the important thing is to look at the whole body, not just at the region where somebody is experiencing something, so you can get the full picture. So I think that is very exciting. It's going to shed a lot of light on disease mechanisms. That's just a few of the things. There are more, but we can talk more offline.
Yeah, there's so many exciting opportunities out there. Here in Australia, there's been some progress in terms of gender equity in the professional sciences, including medicine, health, engineering, and agriculture. Progress has been slower in the traditional or hard sciences like physics and chemistry. What are your observations with respect to gender balance in STEM?
Yeah, in Australia or just in general?
In general.
Yeah, in general. I mean, it's been a while since I've lived in Australia, unfortunately, but I know that I can speak from my experience here in the last 13, 14 years. I've seen things getting better and better, which is great. It's really encouraging. It was certainly a challenge. I'm not going to be shy about that. I think the biggest challenge was looking around and not seeing anyone like me, if that makes sense. Like I just didn't have any female mentors for my whole sort of early stage of my career. It's only been more recently in the last 5 to 10 years, I would say. But prior to that, like going through high school, university, PhD, until I came out here, it still took me probably another 5 years. I just didn't have any. And why is that? They just weren't really around or as accessible. There weren't as many. And that's a known fact that, you know, women in these fields, we just don't have as many that are in positions of leadership. So it's not really a pipeline issue. We have a lot of women. It's like a 50-50 basically in undergrad, or maybe even slightly higher for women in the sciences, but then they drop off. And why are they dropping off? I think there's many reasons, and that would be a whole other conversation. I think that there's not necessarily enough support for women-based issues, or just, you know, people look around and they don't, like I said, they don't see people like them. They don't have that support network. That was something that I definitely experienced. And it's something that I talked to my brother about it, and he's wonderful. And he said, you know, you could leave, but if you left, somebody's going to come up through the pipeline and then look around and be like, oh, there's no one here. You know, you'll go to conferences, they'll go to conferences and have the same issue that you had, but it's like predominantly, you know, one kind of person. And it's then, you know, they'll look around and they'll leave, and that'll keep happening because they'll think, do I fit here? Do I really belong? So he said, you know, you got to stay. You love this. And I said, I do. I love this. So I stayed. I stayed for that reason. And I think a number of people stayed. And now it's slowly becoming better and better and better and better with all sorts of networks to support and encourage women, and sort of building a community so that people feel like, hey, I do belong here. I have a seat at the table. I have a lot to offer. And, you know, I can chat with X, Y, and Z person about what I'm going through right now. Or, you know, if I'm thinking about, you know, things that are more sort of gender specific issues you want to raise. So now I actually have a lot of wonderful women mentors, and I've been able to stay long enough that I've created my own sort of environment where I can welcome women and people of all sorts of backgrounds into my lab. I want to create a safe environment for people to grow and flourish. And that's what you can do, you know, if you stay, and then you can have more sort of an impact in that area. And I have a lot of great friends that have done the same. So I feel like there's a nice cohort and network of people now that we're all about the same age, and we've got trainees just under us that are starting labs. And I see a really positive change in that area. But of course, there's still a ways to go with, you know, pay isn't always equal. And there are things that are still a bit weird that I'm like, why is it even like that? So we've still got some fights to fight, but I think it's getting better.
Yeah, that was a really great answer. Okay. You have won quite a few awards, but I wanted to ask about the importance and significance of 2 of those. First, the Science Teacher of the Year award at Stanford University in 2019, and then the Suffrage Science Award in 2016.
Yeah, so the teaching award was something that I got nominated for. It's sort of like a vote from the students. And I love teaching. So I was really thrilled to be nominated and to win that award. It's basically, I teach a course for bioengineers at Stanford. on molecular imaging and probe development. And so it was based on that, as well as based on how I'm mentoring and teaching students throughout the whole of the molecular imaging program at Stanford, just within their research projects. So both teaching lectures and more hands-on teaching within the lab, teaching various techniques or mentoring people on their career development and trajectories. So the whole spectrum, and it's just what I love to do. So it was really nice to receive that. And then for the Suffrage Science Award, that I got nominated by Sarah Bondic, who's over at Cambridge now. So how it works is somebody who's gotten that award before will nominate someone that they think is deserving of the award. And the award is to recognize achievements of women in science and also their ability to inspire others. And it's to build this network again of women to really encourage and lift each other up. There's just a lot of great women within that group. And I go to the award ceremonies, or at least it's been on Zoom the last couple of years, each time it's on, and it's nice to see the new people that are being celebrated and that we keep growing this family. So that's does that make sense? Any questions about those?
Yeah, that makes sense. That's amazing, and obviously well-deserved awards.
Thank you.
During your career, have you encountered barriers or challenges that were gender-based? And if so, how did you navigate those?
Yeah, I mean, I think it was mainly, as I said, the barriers were more on the side of mentoring. And then, but I was able to find a number of great mentors, and we'll talk a little bit more about that in a minute, but I'll stay on this question right now. I think one of the challenges was, balancing. It's sort of this tightrope where you're balancing a lot of things as a woman and how you're portrayed, whether it's, if you speak, if you're too nice, people are like, oh, there she's a pushover. But if you're too assertive, people say, oh, she's aggressive. Whereas men don't get held to that standard necessarily. It's like, it's not the same. Unfortunately, it just isn't. And I think it is changing, but it's, I was getting a lot of input from different people, mentors, colleagues, and friends about this as well, reading a lot of books. I didn't want to let any of that deter me, but I think Sam had always said to me, the further up you go, the more you'll see some of these issues popping up, but don't worry about it. Don't worry about it. Just put your head down and you do good science, focus on doing good science and getting your papers out. No one can argue with good science and good papers, and you just keep being yourself. You're a good person, and that's it. Because, there are a lot of things, and this is in any career, that will come up along the way to try to deter you, or, political things. But if you have good mentors and friends and family you can talk things through with, and that's all you need. And like I was saying just in a couple of questions ago, the answer was just having that network of mentors in the community. I think that's everything. And I think we're getting more and more inclusive and mindful of just people's different needs and where they're coming from. And I love that. So I think we're in a really good time. And I'm excited for you for the future, because I think it'll keep getting better, and you'll be part of making that even better.
Yeah, I really hope so. As a woman, do you feel pressure to trade off career versus family? And do you think gender plays a part in work-life balance?
Yeah, so it does. I think gender does play a role. I don't have kids at this stage, but I'm really thinking about it. I would like to, and I wonder about, I think I haven't yet, because I'm always like, oh, is it a good time? Is it a good time? And it's never a good time. And I think it's especially tough for women, because you're in your childbearing years at the time when your career is just taking off and you need to be working hard and getting things out. So years have flown by, and I haven't really felt like it was the time until more recently. But that's okay. And there's so I think it does play a role. But if you have a good partner, everything is possible and it's great. And I think that that's the main thing. Or you can do it by yourself, and just have very clear boundaries, or have a supportive family network as well. But I do think that community, or just having your own boundaries is important. I, haven't felt like work-life balance necessarily for like the most part of my career. I haven't felt like it was affected by my gender. I actually just felt like, oh, I just love my work. So I'm working all the time, but I don't feel like I'm working because I love it. And so I probably didn't have the best work-life balance, I have to say. And I didn't think that was a problem until I got a little bit sick. Like I had some pain in my body, and I think my body was telling me, hey, you need to slow down, or you need to do some other things. And I talked to Sam about it, and he said, I'll never forget it. He looked at me and said, don't do this to yourself. Don't do what I did. Like, you need to prioritize your health. And even if you love doing this every day, that's great, but you have to take a break to do other things you love too, to let your body rest, let your mind rest, do other things. So that was probably my biggest barrier, was just my own love of the research, and, being driven to keep working because I enjoyed it. But I've now since then really realized the importance of the balance side of things, which is just giving yourself the time and space to have a rest, to take a bubble bath, to take a walk. I got a dog 2 years ago now, like at the beginning of the pandemic, and she's an absolute delight. We go for lots of walks. I just got married recently, and we just have a wonderful life, and we protect our weekends, but we work hard during the week. So it's just, I think everyone's on their own journey for finding what that means for them, work-life balance. And it's great when you find something you love. It's also important to take care of your body, I would say.
Yeah, it's an important balance, and in the future, hopefully it doesn't require sacrificing career or family.
Yeah.
What have you drawn on most in balancing personal and professional lives?
Yeah, I would say like those things that I was kind of saying, just sort of talking to folk, like getting advice from mentors is like a big one. And, putting things in perspective and thinking, if I if I keep doing this, like time, you have sort of finite time as a person on, living in this world. So what do you want to do, and what can you do, and what's most important? And I think having significant life events where you lose someone, like when I lost Sam, or other family members, it puts things in perspective, and you think, okay, like my work's important. It's also important to prioritize family time, to prioritize, just things that you love, or things that can just add to the community or to what you're doing, sort of feeding into your purpose in other ways, and just to rest. So I think just that's probably where I draw most of my inspiration from, and just having fun, and I had fun at work. So like, that's why it was a little bit of a blurred line, but, doing other things that are also fun. So that's, and it is a balance. And it can change season to season, and that's okay. That's the other thing to think about. Like, you don't have to feel like everything is in a perfect balance all the time. Sometimes there will be periods where you just have to work a lot more, and other times it'll be more that you're focusing on family more. Maybe, with caring for a parent, or having a baby, or whatever that may look like. I think you have to be flexible, and you have to be kind to yourself. And you have to say, hey, this is okay. This is where I'm at right now. And I'm gonna do this to the best I can. And I'm gonna give myself grace when things fall through the cracks. That's okay. And yeah, that's it. So just flexibility is important.
Yeah, it's really great insight. Is there anything in radiochemistry, radiopharmaceutical science, or pharmacology that's important or contentious you would like to see the next generation work on?
Yeah, there's a lot of things. I think multi-tracer imaging, so being able to sort of do multiplexed PET imaging would be something I'd love to see happen. I think I've seen little glimmers of it, and I know there's some collaborators of mine that are working on it, and I hope that a lot of different teams around the world will work on it and we can make it a reality. Because I think that right now, just being able to look at one molecular target in the body, that's great. But we know that things are very complicated. So if you think about the immune system or cancer or neurodegenerative diseases, there's multiple things going on. If we could visualize multiple targets, cell types, simultaneously, I think we could extract out a lot more meaningful information, so we can understand the relationship between these various biological events. And so that's one thing I would say. Another thing that I was thinking of, certainly better understanding mental health, different psychiatric diseases. That's something that I'd love to see more people working on. It's a big black box at the moment for a lot of these conditions. And I think we're going to see more of them coming out of the pandemic. People feeling very isolated. And I know suicide rates have gone up, unfortunately. And so we really need better ways to understand what's going on in the brain in diseases like schizophrenia or bipolar or depression, so that we can better treat and support these people. Also, sleep is another one. I think we need to understand better and be able to optimize, because honestly, I think we underestimate the importance of sleep and the role that it plays in mental health as well as your physical health. There's a study that I'll never forget. I just can't get out of my mind, with people that had chronic insomnia and they didn't sleep for a number of days, however long it was. When they scanned their brains, they actually looked like an Alzheimer's brain. They had that kind of pathology from not sleeping and having this chronic insomnia. So I think, hopefully we'll be able to work on a way to better prioritize and optimize sleep so we can take care of our brain health.
Yeah, that would be really great to see.
Yeah.
Are there any experiences from your journey that might inspire the next generation of women in STEM?
Yeah, let's think about that. I think that, there's a lot of things. I would say one experience in particular that I hope inspires or at least encourages women of the next generation in STEM is that we all feel like we're imposters. All of us, everyone, not just women, men as well. And I have a story for you. This happened early on when I joined Sam's lab at Stanford. I was 24 when I first flew over to the States and landed at Stanford, and I was looking around like, whoa, how am I here? And, just a girl from the Shire coming over and landing there by myself and thinking, my goodness, I would be sitting in lab meetings, and the sorts of science that they were talking about was really incredible. And I was, just starting to doubt myself. Am I even supposed to be here? Anyway, then this email pops up saying, do you feel like you're an imposter? Do you feel like you don't belong here? Do you feel like you're not smart enough? And all of this stuff. Come to this seminar. And I was like, oh, that's cool. It was just to the Stanford mailing list. And so I went down there and kind of walking down, hiding a little bit, like I hope no one sees me. And then it was over flooding. They had so many people trying to get into this lecture. They didn't have room. So they had to have two overflow rooms with big screens. And this is at Stanford. And I got in and I was sitting down and I looked around and I saw John Ronald, who's an amazing researcher up in Canada, who was in the lab with me. And I was like, what? I was like, you think you're an imposter? He's like, what? You think you're an imposter? And we both thought the world of each other and thought each person was amazing. And I was like, yeah. And it turns out just everyone thinks they're an imposter. That's all I want to say. And I think we just need to recognize that we have that. Everyone just has that. And actually, it's a good sign to be like, you know what? Yeah, I have this. And it's better than, I think the alternative is if you think you know it all, that's actually a negative. That's not good for being a scientist. I think the more science you do and the more life you do, the more you realize you just don't know. And that's okay. and just feeling comfortable in that, and confident that you're doing your best, and you're doing great things, and everyone feels like this. It's normal. So accept it and move on. So that's probably my words of encouragement or inspiration. I think after that, I didn't have a problem with it. I was just like, well, everyone feels this. It's okay.
There's a lot to learn from that.
Yeah.
For young women, what are the essential skills you think they need to craft and navigate a career in STEM?
Yes, I think that for a career in STEM, so it's pretty broad, but I would say, one, obtain a very solid foundation in the area you want to work in. So if it is in medicine, if you want to be a medical doctor, or just medical research in general, having a strong biology background is important. In chemistry, of course, you want to have the strong chemistry background. Whatever you're doing, just have a very solid foundation, but don't just be like everyone else. You need to stand out. You need to set yourself apart. So I would encourage people that are really serious about a career in STEM to look into and to get mentoring from people in the field, do a lot of reading, talking to experts. What's the hot new thing? Or what are the areas that, where's the field moving? What do you need to know about? So do you need to know more about AI? Do you need to know more about, theranostics? For me at the time, I fell into radiochemistry, and actually it was a really wonderful skill to learn early on, because it turns out not so many people know how to do that around the world. And so anyone who is asking me, like, what would you advise me to do to position myself well to have a career in imaging research, I say learn radiochemistry if you can, because it's a great skill to have. It sets you apart. But it could be anything, if you're these sort of multiplexed ways of looking at the immune system. There are different new, really fancy approaches for that. So I just say, find out what the latest approaches are, learn that, master it, and then even start thinking about newer approaches. You always have to be thinking and being on the cutting edge and setting yourself apart. Because if you're just a regular biologist, they're a dime a dozen, and you need to go further. You need to be pushing the field forward and thinking about that and getting those skills. When I look at hiring people or having interns in the lab, I get a lot of emails, as everyone does, because there's a lot of interest to do this kind of work. I look for attitude. It's all about attitude. So if somebody's writing to me like, "Hi, Michelle, I read about your work and I'm really passionate about X, Y, and Z," if they're telling me about their story, if they seem genuinely excited and kind, gracious, and humble, and that they're willing to work and really put in the work, be gritty, I think that's more important than having any skill. Actually, we could teach you any skill you want. You can learn how to do PET imaging in a week. But I need someone who has a good attitude, who's positive, kind, ready to learn, is ready to work hard. And you'll be surprised, it's not so easy to find. But every now and again, they come along and I'll snap them up. I'll say, "Yes, come on in." And they usually have no background at all. So I'd say attitude is really important as well.
Yeah, that's all really amazing advice, and I 100% agree. One question to finish. Do you have any other pearls or pitfalls to offer young women in high school with an aptitude for STEM?
Yes, I do. I think that, like I had alluded to throughout this interview, mentoring is so important. Be a mentor and be mentored, and have a network of mentors. That I can't overemphasize. I would say it's so important to get sort of advice and feedback from people at different stages and for different reasons. And people love being asked to mentor young people. They get very excited and they're honored. So I think being proactive. So for instance, it's good to have a mentor who's one step ahead of you. So you're in high school right now, having a mentor that's in doing their undergraduate research or work at university. And then if you're thinking about medicine or a career in research or whatever you're thinking next, going into business, have a mentor, someone at that stage, an early stage, and then have someone who's at a very senior level, maybe in a different field, And maybe you have a mentor for different things, somebody who's more about going to help you with your CV and help you on your way for your career sort of development, and maybe someone else that's going to mentor you on just teaching you new things about specific techniques. So different mentors for different things. Having that network of people, never be afraid to reach out to folk. If you just see them online, you've met them at a conference or a meeting, or you've read a paper or whatever it is, reaching out never hurts, and just be really genuine and honest. And I think that, you know, people will always give up 30 minutes, even if it's just 30 minutes a few times a year. That could be a really life-changing experience for you. And I think the mentors in my life, Michael, Sam, and others, have really opened up a lot of opportunities for me. And it's really changed everything, like really just changed my world and what I was able to do because of that. And then I'd say just to be bold and be creative. Don't be afraid to be creative. Do something different. Put your own spin on it. And I think just go for it. Like put your head down in the face of adversity and keep going. Like I think staying in the game is the most important thing. Just staying and doing good science. So yeah, that's probably my best pearls of wisdom that I've gathered over the last over 15 years now.
Yeah, that's a really awesome way to finish. Thank you so much.
Thank you, Josie.
Once again, I want to thank Dr. James for her incredible insight and for taking the time to not only speak with me, but also inspire the next generation of women in STEM.
Thanks for having me. It's been a pleasure. And I'd be happy to chat with anyone if people want to reach out, email. I'm happy to have a call. So yeah, good luck to you all.
Thank you so much.